Have you ever asked something to ChatGPT, developed by OpenAI and launched on November 30th, 2022, and were stunned by its response? It seems almost magic. But what really happens when you press send? How does a machine, powered by large language models like ChatGPT Turbo with 175 billion parameters, understand our words and generate text that seems written by a human? Today we open the black box. We'll travel inside ChatGPT to reveal, step by step, the technological mechanisms of the GPT series that make it work. And I assure you, it's more fascinating than magic, rooted in advanced statistics and computational power. First, let's debunk a myth. ChatGPT doesn't think or understand like us, as noted in critiques like, "On the dangers of stochastic parrots." Imagine it differently. It's like a super librarian who, when you ask a question, races through the equivalent of billions of pages from 570 gigabytes of training data, including Common Crawl, WebText2, Books 1 and 2, and Wikipedia, totaling around 300 billion tokens it processed during training. It's not magic. It's speed, statistics, and math. Its sole purpose is to calculate the most likely sequence of words to respond to your request through autoregressive next token prediction, based on patterns it learned. Everything starts with your prompt, the question or instruction you write. The first thing the system does is a process called tokenization, using byte pair encoding from OpenAI's TikToken library. It breaks your sentence into smaller pieces, tokens. A token can be a whole word like house, part of a word like origin, or even punctuation. For example, how does artificial intelligence work isn't read whole, but split into about 7 to 10 tokens like how, does, artifix, intel, agents. The vocabulary size is around 50,257 for GPT-4s. This allows the model to handle language more flexibly, with average English words taking about 1.3 to 1.5 tokens, and context up to 4096 tokens for GPT 3.5 or 128,000 for GPT-4. But computers don't understand words, only numbers. Here comes the second step, embedding. Each token is converted into a long sequence of numbers, a vector, such as 12 to 88 dimensions for ChatGPT. This isn't random. Vectors are created so similar, meaning words have similar numeric vectors, inspired by Word2Vec geometry. Imagine a giant star map. King and queen are close points like dog and cat. Apple near pear, far from car. This turns language into mathematical coordinates, capturing relationships in context, as in king minus man plus woman approximating queen. Now that our question is a series of meaningful numbers with positional encodings, the beating heart of ChatGPT comes into play, the decoder-only transformer architecture. This was a real revolution, introduced in 2017 in the paper "Attention is All You Need" by Ashish Vaswani et al. From Google Brain. Its key component is the attention mechanism. As it processes your request, attention weighs each token's importance relative to others using multi-head self-attention. If you ask, what is the capital of France, the country famous for the Eiffel Tower? Attention focuses on capital and France, less on famous or Eiffel Tower. This lets the AI grasp nuances and complex dependencies, even between distant words, via the attention matrix computing softmax V with causal masking. The transformer architecture, with its attention mechanism across 96 layers and fine-tuned via reinforcement learning from human feedback, is what allows ChatGPT to generate human-like text, making it a truly remarkable technological achievement. Welcome to our channel. Please show your support if you enjoy the content. Tap the like button to help us reach more viewers. Don't forget to subscribe so you never miss our uploads. Hit subscribe and ring the bell for new content. But how does the model know that after the phrase the capital of France is, the most probable answer is Paris? The answer lies in its training. Before our use, ChatGPT spent months on powerful supercomputers, analyzing an almost unimaginable amount of text. Books, Wikipedia, scientific articles, conversations, a whole slice of the internet. This phase, called pre-training, is used to build its statistical knowledge of the world. But it's not enough. Subsequently, the man intervenes. Thousands of specialists perform a process called fine-tuning with human feedback, or RLHF. In practice, they dialogue with AI, evaluating and correcting its responses, teaching it to be more helpful, honest, and secure. So, behind every answer, there is not only the machine, but also the invisible work of thousands of people who trained it. This incredible computing power, however, has a hidden and very tangible cost: energy consumption. Every single question we ask initiates a process that requires a huge amount of energy. Think that training a model like GPT-4 required a power comparable to the annual consumption of hundreds of homes. And daily use is no less. It is estimated that a single conversation with ChatGPT can cost, in energy terms, the equivalent of recharging your smartphone dozens of times. It is not a zero-impact operation. Behind the interface cleaning are data centers that consume energy and generate heat. It is a fundamental aspect to consider when talking about the sustainable future of AI. Being a probabilistic model trained on existing data, ChatGPT inherits two intrinsic limitations. The first is bias. If the training data contain prejudices, AI will learn them and reproduce them in its responses, sometimes in very subtle ways. The second, more well-known, is hallucination. When the model does not find a statistically strong answer, it does not say, "I don't know." Instead, invent the most plausible-sounding answer, mixing real facts with completely false details. It can cite non-existent books or invent biographies. For this reason, it is a very powerful tool for creativity and assistance, but not a source of absolute truth. The human verification remains indispensable. In conclusion, ChatGPT is not a sentient mind, but a revolutionary tool based on mathematics, vast amounts of data, and fundamental human training. Its functioning teaches us a lot about language, but it also presents us with new challenges: energy consumption, biases, and the need for critical thinking. Learning to use it means understanding its power, but also its limits. It is a co-pilot for our intelligence, not a substitute. If this in-depth look has given you a new perspective on artificial intelligence, leave a like and subscribe to the channel. Together, we will continue to explore the technologies that are shaping our tomorrow. See you next time.